Poolside's new Laguna S 2.1 faced this DeepSWE task 3 times in thinking mode. 1 attempt passed, 2 failed. The pass is real. It applied a 50,703 byte patch to the ABS language repository and cleared 20 feature checks plus 3 regressions. But the 1 out of 3 split is the better hook because it shows exactly what a benchmark average hides. This model can finish substantial work. It can also spend a long rollout going nowhere, so we are starting with the artifact, not the launch slide. Laguna S 2.1 is Poolside's new open-weight coding model. 118 billion total parameters, about 8 billion active per token, and up to a 1 million token context window. It sits between the smaller XS line and the larger M model. Poolside released BF16, FP8, INT4, NVFP4, GGUF, and MLX variants under the OpenMDW license. The important product idea is long horizon agent work with thinking either off or max, rather than a general chat model dressed up with a terminal icon. Now the benchmark contract. Datacurve's DeepSWE version 1.1 contains 113 tasks across 91 repositories and 5 languages. Its public leaderboard standardizes models through mini-swe-agent. Poolside did not submit this result through that exact path. It says the 40.4 score came from Pool, its own agent harness running on an internal harbor fork configured to resemble DeepSWE's peer harness. That is not a reason to discard the number. It is a reason to label it correctly. Same task set, different scaffolding, not a controlled official leaderboard row. Poolside reports 40.4% with thinking enabled and 16.5% with thinking off, averaged over 3 attempts per task. That 23.9-point lift is the main Laguna story. Test time reasoning is not a decorative toggle here. It changes which engineering problems the model can finish. Poolside also published every final run trajectory, which is unusually helpful. Still, this is a maker-reported score in the maker's harness. The public DeepSWE table uses mini-swe-agent. If a comparison chart places those numbers in one ordered list, the harness label needs to remain attached to the bar. The passing task asked Laguna to improve module loading in the ABS programming language. Requirements included deterministic canonical path caching, module discovery through ABS module path, cache inspection functions, cycle handling, debug tracing, and command line flags in script mode. The archive shows 137 agent steps, 134,600 output tokens, 17.5 million input tokens with most served from cache, and a reported cost of about 21 cents. The verifier records 20 of 20 new checks and 3 of 3 regressions passing. That is meaningful repository-level work, and the downloadable trajectory makes the path inspectable instead of mystical. Then the scoreboard printer jams. On this same task, still in thinking mode, the other 2 attempts failed. One ran 185 steps and cost about 39 cents. The other ran 139 steps and cost about 24 cents. More steps did not buy a pass. 2 failures do not erase the successful patch, and 1 success does not guarantee the next rollout. This is why pass at 1 needs multiple attempts, and why production teams should track retry distribution. Your incident channel will not be comforted by learning that the model was statistically impressive on Tuesday. Poolside's own limitations section helps explain why harness engineering matters. Laguna can struggle with slightly different third-party tool schemas, especially on the first tool call. Nested tool arguments can produce invalid JSON escaping. And max thinking may continue for long sequences before making progress. Poolside says some schema mistakes recover after the harness rejects the call and the model learns in context. Useful, but that retry still costs latency and tokens. The model and harness are a system. Testing only the checkpoint while ignoring tool definitions, error messages, step caps, caching, and sandbox behavior is testing half the product. What did Poolside change? Its account emphasizes behavior, more verification, less premature victory, more willingness to backtrack, and longer persistence. The training mix reportedly spans 409,000 environments, including 168,000 software engineering setups and 83,000 terminal setups. Poolside also used longer rollout budgets and multi-harness rollouts, while the 1 million token context gives long sessions room to accumulate. Those are maker claims about the training process, not conclusions from one trajectory. But they line up with the product thesis. A relatively small active model can compete by working longer and checking itself more often. The verdict is promising open weights with a comparability asterisk. 40.4% on DeepSWE in Pool is a strong long-horizon signal for an 8 billion active model, and the passing ABS patch proves the model can deliver a substantial repository change. The 1 out of 3 task result and Poolside's harness disclosures say exactly what to do next. Run representative tasks in your own agent. Use at least 3 attempts. Hide tests the model cannot edit. Record schema errors, retries, total tokens, wall time, review effort, and cleanup. Then compare complete delivery. The benchmark gets Laguna into the trial. Your harness decides whether it stays.